Here in the district, we have 2.3 million square feet of green roofs within just 69 square miles. That is amazing. But we're not stopping there. We're adding more than 1 million additional square feet of green roofs over the next 10 years. And we're well on track to achieve or even exceed that goal.
These elevated green spaces range from small residential rooftop gardens to vast spaces on commercial real estate and government buildings.
The District Department of the Environment, or DDOE, calls them RiverSmart Rooftops, and for good reason. In addition to providing beautiful landscapes, green roofs also protect our creeks and rivers, and ultimately the Chesapeake Bay, from pollutants and harmful nutrients in stormwater runoff. The District Department of the Environment has a 10,000 square foot green roof. When it rains or snows, the plants on this roof absorb water. Even in winter, when plants are dormant, they reduce runoff by up to 50% of that of a normal roof.
A green roof doesn't have to be atop a house or high-rise building. In the District of Columbia, there's even a green roof above a traffic tunnel with trees that grow to be 50 feet tall.
We're at the U.S. Tax Court, and this is one of our unique properties where we have a plaza extending over top of a highway. So we have a lot of carbon dioxide that is coming up, flowing through the site, and we have a building that's behind it that has a cantilevered roof that can't support the weight of a green roof. So what we've done here is we've taken the water that flows off the roof, captured it in cisterns in the bottom of the building, and we pump it out onto this plaza where we have planted an ancient species of tree, Taxodium disticum, that can literally live in standing water. We actually utilize nature, the power of these trees, to pull that water up out of the ground and to release it into the atmosphere rather than having it percolate into the ground. This site processes more than 30,000 gallons of storm water a year, and it's about 20,000 square feet of planted space. And this plaza that we're standing on is actually perforated with vents. And the vents serve as chimneys that bring the CO2 from under the plaza directly into the canopy of the trees. And then this is the vent where the CO2 comes up, feeds the trees. You can see how it really grows right over it. The federal government is the largest property owner in the country, and there is a distinct recognition of the importance of the environmental mission and the fact that we need to deal with stormwater, climate change, etc. So almost every new facility is built with a green roof, and as many facilities that can be retrofitted with one are being.
Washington, D.C. has the same issues with stormwater that any urban area or very densely developed area. The challenge is what to do with that rainwater and make it a resource. How can we hold it in a place and think of it as an asset rather than a problem when it rolls off the land? Where we are standing now is actually on top of a reservoir, Fort Reno, which is one of the highest areas in all of Washington, D.C. But on top of that, we've built a green roof. It's going to capture rainwater and hold it on site rather than having roll off and down into the rest of the city. The plants that are growing here are going to be absorbing nutrients that we don't want in the rainwater, so it's water quality. As the plants grow, it's providing habitat. It's actually reducing heat island effects of what a hard roof would have caused, reducing ground level ozones. Then there's the next one, the kind of jobs we'll create. So there's a whole series of benefits. It's a great investment for the city and for the environment.
Green roofs are generally described as extensive or intensive, depending upon the depth of the growing media and the variety of plants. Extensive and intensive green roofs are built the same way. However, their components will vary in size and strength. An extensive green roof requires as little as 3 to 4 inches of growing media. This adds a roof load of about 15 to 30 pounds per square foot. Plant diversity is generally limited to sedums, hardy succulent plants with water-storing leaves. The advantage to an extensive roof is that it requires little to no irrigation and less maintenance. Expect a cost of about $10 to $30 a square foot more than a conventional roof. An intensive roof needs at least 6 inches of growing media, which increases the roof load by more than 45 pounds per square foot. Depending upon media depth, plants include vegetables, trees, shrubs, and perennials. Maintaining an intensive green roof requires routine care and irrigation. Expect a cost of at least $40 per square foot above the cost of a conventional roof.
So this is preparation of the roof, just getting whatever debris is on top of the roof membrane out of the way.
We spent a day with Peter Ensign and his crew at DC Greenworks as they installed a green roof on an urban townhouse. This team used a motorized lift on a ladder to get the materials up to a second-floor terrace before carrying them up another flight to the third-floor rooftop. This townhouse was renovated to sustain a green roof, so it's already structurally sound, and the waterproofing membrane has been installed.
So what is being rolled out now is root barrier, so that the plants will not penetrate beyond this, through this material, and get down to where they can affect the membrane.
Many contractors lay a protection fabric over the root barrier to avoid damaging the membrane during installation.
So what we're bringing up now is the drainage layer, which are these, rigid recycled plastic sheets that look like egg crates, but they're really a little more sophisticated than that in that they have these very small holes up at the top, so any overflow will go through to underneath the drainage layer and be able to run out to that scupper. The edging is about 6 inches in height. We're going to have a 6-inch deep media base, and then the plants will be planted into that. What this edging does is it separates the media and the plants from the perimeter, which is going to be filled with a stone ballast. This is called 3/8 of an inch aggregate. It's a pebble, so it's smooth edged. It's taken from river basins, and it'll sit in the perimeter of the roof area, just outside of where the green roof is going to be. It's very important that as a part of the installation, that the materials overlap one another. So starting with that root barrier, then protection fabric, then this drainage layer, and now this filter fabric, you can see that there's an overlap. This is about a foot overlap. We want to make certain that there's no way that the media, when it's piled on top of this, that it'll slide underneath and cause a problem in clogging the drainage layer below. We bring the filter fabric up and above the edging. When everything is installed, then we come along with a pair of scissors and we cut this edge very cleanly so that you never see it. So now that the filter fabric has been placed, we're beginning to fill the green roof area with the media. This is called growing media as opposed to soil because it has a very small organic content, typically about 10%. The rest of it is mineral and mostly made up of slate. The organic material is compost. It's a sanitized compost that has sat and been cared for long enough that it's completely sanitary. After the media has been installed, we then rake the surface to level things out. And then we take this portable tamper that we fill with water that makes it quite heavy up here on the roof deck, and then roll it over the surface to compact it. And then we can water this down and begin to plant. And there's a variety of plants that have been selected for this rooftop. We have some native grasses going into the corners. We have some black-eyed Susans along the side. And then we're going to have an area here in the front where there'll be other sedum plants. Once all of the planting is complete, then we will water it down. We're going to put some mulch, and we're also going to run a temporary irrigation line so that when the homeowners are not at home, it can automatically be set with a timer to water the plants through the rest of the summer. So what we'll end up with is a beautiful green roof here on top of this townhouse in the middle of the city, filled with a wide variety of plants that over the next year will begin to really fill out and totally cover this area and be a native landscape here on this row house.
This residential green roof crowns the parking garage at the Sheridan Station Apartments in southeast Washington, D.C. Tenants may not even realize that their safe, beautiful green terrace has another important function: keeping nasty stormwater runoff out of the nearby Anacostia River.
I'm glad that it's here, and the space is being utilized by not just the adults but the children. We don't want the residents to congregate on the front of the building, and so we wanted to provide them with a gathering area.
In addition to the environmental and aesthetic benefits of these roofs, green roofs also have economic benefits. They protect the underlying roof finish, which lasts 3 to 5 times longer, increases property values and marketability, provides credits for stormwater impact fees, and saves energy costs.
We're in 16th Street Heights, which is in northwest DC, about 3 miles north of the White House. And it's a residential neighborhood with predominantly row house construction, all built around 1920. And for the most part, the roofs are quite flat, which is very friendly design for installing a green roof. So besides the stormwater benefit, there's also the additional benefit to the heat island effect, which is an external benefit, but there's some internal benefits inside the house, which I should definitely mention. I almost didn't use any air conditioning at least one of the 2 summers after installing the green roof, and energy bills plummeted.
Commercial green roofs are built with the same or similar layers and materials, depending on the scale and the site conditions. Incorporating a green roof into the design of a new construction project saves time and money.
The goal of our firm and probably many other firms is to try to develop as green a building as possible. And one of the ways to get there is through the use of a green roof.
We joined the contractors at 175 N Street Northeast in the Noma neighborhood as they poured an asphalt membrane suitable for an extensive green roof atop this new commercial building.
This roof has about 22,000 square foot of green roof on it over a hot rubberized asphalt. It's a solid mass of rubberized asphalt, but we put that into a double jacketed melter, which works like your double boiler in your kitchen. So we heat it up to about 400 degrees in temperature, and then we pour it out of the melter, and we spread that across the roof system in 2 defined layers. First coat goes down, we prime the concrete, then we put down a base coat. We set in a scrim kind of fabric, almost like silk, and we brush it in with a broom. And then before it all cools off, we hit it with another coat. So the total system is 215 mils by the time it's all said and done.
In 2013, DDOE inspected over 30 green roofs totaling 400,000 square feet.
So how many drains did we end up having on this roof again?
I think there's about 10 or 12.
10 or 12. And most of them, as I saw, are in pretty good shape. Just some of them have gotten a little bit of media that's kind of spilled in there.
Inspections cover everything from deck preparation to waterproofing to the components of a green roof.
This section that we're presently testing, how long has the water been standing?
The flood test on this particular section has been going on for 48 hours. We'll keep it till tomorrow morning. We'll drain it down and then set up another section for flood test.
Have there been any leaks at all?
Back in our corner, we had one little one at our perimeter, but what we did, we block off that area, do the repair, put the water back on it.
So this is an extensive green roof. Generally, we come out and take a look at it when it's being installed, as well as afterwards, to make sure it's consistent throughout the roof. And it's about, what, 4 inches here?
The materials we use, they look like coffee grounds. It does a very good job of absorbing water and holding on to it and letting anything that's over and above what it can hold on to flow right out.
If we have a really heavy rain event, some water will go down through here.
We get some storage on the roof for the plants, and we get the rest of it flowing out into the roof drains and down into the storage cisterns in the basement.
So these represent the roof drains that are the overflows for the green roof.
Yes, sir, that's correct.
And where do they go from there?
The rain leaders come in, tie into a main leader, go down at various columns and go down into our cistern, into our gray water tank, which is reused through the building for irrigation, watering the plants on the roof and toilets.
When National Public Radio moved to its new location on North Capitol Street, energy efficiency was a high priority for its new headquarters. NPR's new green roofs not only save energy, they provide environmental and aesthetic benefits.
Right now we're standing on a 4-story historic structure, and there's a 7-story office building behind me. From the beginning, we understood that this roof surface would be very prominent and very visible from the occupants inside the building. So it was incumbent upon us to create a green roof surface that was both dynamic and evocative and provided visual interest. Every day, NPR holds an open tour to the public. The green roof is a major stopping point on this tour, and it's a brilliant way to reinforce the notion that NPR is an organization that understands the value of environmentally sensitive design. It's a huge billboard that just says, yes, this is what we're trying to do, and this is our step at helping the environment. In addition to the extensive green roofs on the major roof surfaces, we also have small pockets of intensive or deep green roof systems on the occupiable terraces that are amenities for the employees. The advantages of an intensive system, the advantages of a thick soil medium, is that the landscape architect can choose from a much wider palette of plants, and we see a much more lush and diverse growth selection.
The environmental benefits of a green roof contribute significantly to LEED certification. LEED stands for Leadership in Energy and Environmental Design. This certification was developed by the U.S. Green Building Council to set a standard for design, construction, and operation of high-performance green buildings.
In many jurisdictions, LEED certification means tax breaks and other financial incentives. In the District of Columbia, LEED certification is required for all new construction and major renovation of larger federal, district, and commercial buildings.
This office building at 1425 K Street Northwest was the first commercial building to transform wasted real estate into a beautiful space with environmental, aesthetic, and social benefits. The green roof also contributed to its LEED certification.
So in 2003, I was new here at the property, and a woman by the name of Barbara Deitch with Casey Trees, who is our smallest but most vocal customer in our building, barged into my office and said, "Hey, I'm Barbara Deitch with Casey Trees, and we want to put a green roof on this building." And I was like, well, I've only worked here a few weeks, and I don't even know what a green roof is. So let's talk about it. So that was in early 2003. A year later, we put the district's first green roof on the building here.
It demonstrates what you can do on any of the roofs here in DC. These are all green roof ready buildings. They can hold the weight. This is the new technology to have these lightweight soils that this roof is demonstrating. So the opportunity though for the public good is large because we started with this little roof.
Most, but not all buildings are green roof ready. Engineers need to evaluate whether the roof has the structural load-bearing capacity and water tightness for a green roof. Some retrofits can be challenging. For example, a roof that is sloped more than 15% will require specialized products to hold the media in place. But retrofits are being built all over Washington, D.C., inspired by the green roof pioneers at Blake Real Estate.
Birds fly in here all the time. One day before a storm, I noticed a blanket of dragonflies that covered the green roof. And I thought, there's no way that we would have these dragonflies here if we didn't have this green roof. When you hear the noise pollution, and you hear the sirens, and buses going by, and the hustle and bustle, it's just a really nice, peaceful place to come.
Imagine what Washington, D.C. would be like if all the buildings had green roofs. Each of those roofs would absorb rainwater, reduce the amount of runoff that now overflows into our rivers and streams, and save the district millions, if not billions, in gray infrastructure expansion.
Many have heard to some extent about our deep tunneling project and wonder what that is and how it might connect with this project. The deep tunneling project is a once-in-a-generation improvement to the fundamental sewer system of the city. When it was originally built at the end of the 1800s, that's how old the system is, there was one sewer system that was put in that handles both sewage, so sewage coming from any building, and rainfall coming off a street into the same pipe. And once the pipe is filled, either you have backups into people's homes and neighborhoods, or you allow overflows to the river. That is what happens by design. It's a terrible outcome. It's just less terrible than overflows to people's basements. It's almost impossible to tear up all the city streets and put in much larger sewers. So what we're doing is building giant underground tunnels. And we're starting on the Anacostia, 10 stories down, 23 feet in diameter, a machine that's a football field in length, to build this huge system to take that overflow. But there is an alternative that has all sorts of benefits based on what you see behind me. If what we are talking about here is stormwater that's going to sink into the ground and not flow off to the street, it'll never get into the pipe in the first place if we can handle it at the surface. And the reason we're doing this project is not only is it good for its own right, but we're evaluating its performance. So as it grows, how much rainfall does it in fact capture? We need to know the characteristics of a green roof from an engineering perspective, a cost perspective, and a maintenance perspective, every bit as well as we know the characteristics of a pipe. And that's what we're working on, and that's one of the reasons we built this green roof.
Green roofs have so many benefits, but to realize those benefits over many years, green roofs require maintenance. For most of us, weeding a garden is a dreaded chore, but for the professionals who maintain the green roofs in DC, weeding is just part of the fun and a chance to commune with nature in the middle of a concrete and asphalt jungle.
You are in Northwest DC on 706th Street, which is a project in Chinatown. It's got an extensive green roof that's about 4 inches deep, and it's one of the older ones in the city.
It looks like this roof has come off pretty nicely. All the areas have been covered.
This was the first building that we built originally with the green roof, and I was involved as the development project manager on this one. The biggest lesson is that you really have to have a good consultant on board early, typically a good maintenance consultant. I think that's probably the biggest thing, is the maintenance afterwards.
The frequency of maintenance depends on the roof. For this project, we're coming out at least every month during the growing season. From February or March, it was March this year, all the way through September, October. And that way we'll be able to get the weeds out before they go to seed and really make sure that the sedums are starting to get established, or any of the other species that are on here. If it's a low visibility roof and it has pretty good coverage and proper maintenance has been done since its establishment, you can get away with a visit just once or twice a year for checkups and general weeding and trimming.
On the first visit, we tend to kind of come out, get the lay of the land, and then on this visit is when the bulk of the weeds are starting to emerge. You kind of have a mixture of winter annuals that are still in place, and then the start of the summer annuals are starting to pop up too. So you get a lot of diversity in weed species right now. Down on the sidewalk, I have to hold myself back from pulling the weeds sometimes. You know, it's bad when you start dreaming about it. So everyone kind of develops their own weed picking style and strategy. I like to think I have a very, very good form. I would consider this to be fairly standard, good condition. You can see lots of good, healthy growth. We're getting right into the time of year where the sedum puts on the majority of its growth for the entire year. So you always want to see fairly, dense sedum growth. It also gives you areas where you can take some cuttings to spread to areas that may not be quite as covered.
Cuttings are something as simple as just ripping off the top of a plant. You can also buy them, but I like cuttings for roofs from roofs. It's a little bit more sustainable. Now, depending on the time of year and/or irrigation is how well you'll get the roof established. But we did put some in, I believe it was March, and you can start to see the little cuttings starting to take root.
This is one of my favorite digging tools. I prefer the thinner blade because it disturbs less soil. The media that's up here is only probably 3 to 4 inches in depth, so you don't want to be removing media, or at some point you'll have to add more. And another is if there is some annual weed seeds that are in the soil, it's best not to disturb them by bringing them to the surface, because then they can germinate and then you have more weeds to pull. In some instances, you may want to use an herbicide, like in some of the non-vegetated areas where it's really hard to remove the entire plant. But you have to do it very, very carefully. You don't, because we're up on top of a building, and if you get a little heavy-handed with it, you can get some of that stuff to blow around, and you can end up damaging the species that you want to be growing there. Occasionally, there's some species of weeds where torching works really well. Again, and you have to be really careful because you're up on top of a windy roof. You know, you want to make sure there's no dead vegetation that could catch on fire. But for the most part, it's all kind of getting your fingers dirty and pulling the weeds out. We're not trying to find any gold or anything, just remove and loosen the weeds as we're going.
The District of Columbia is determined to be the most sustainable city in the United States, and green roofs are part of the plan. To encourage builders and homeowners to install green roofs, the District Department of the Environment offers RiverSmart Rooftop rebates from $10 to $15 per square foot, depending upon the location.
It's a wonderful feeling to not only see how beautiful these roofs are, but to realize and understand the remarkable things these RiverSmart rooftops are doing for our environment. I invite every city and state in America to join us as we transform our rooftops from unattractive, environmentally harmful spaces to beautiful, environmentally friendly places.
I am D-O-E-E.
Yo soy D-E-O-E.
I am D-O-E-E.
I am D-O-E-E.
I am D-O-E-E.
I am D-O-E-E.
I am the Department of Energy and the Environment.